Grade 10s, we worked on completing the square yesterday and it was tough. So I'm going to do 2 more examples for you today, and I've chosen some pretty difficult ones. So the first one is y equals 2x squared subtract 8x subtract 5, and we would recognize that that is now in standard form. So standard form is the form of a quadratic that has no brackets anywhere in sight. So it can be fairly useless, but it does tell us 2 things. The first thing that standard form tells us is that the y-intercept, where you put a 0 in for x, would leave a -5. So that value on the end, once you've removed those x's when they're 0, would be the y-intercept. The second thing that standard form tells us, just like all the other forms, is the a value is 2. That tells us it opens up and that it's skinny. So we have an idea already, but we just don't know where the vertex is for this thing. It would be very difficult to draw. So our goal is to complete the square so that we can write it in vertex form. So the look that we want is y equals a. Well, we already know that's going to end up being a 2. X subtract p squared plus q. Okay, that's our goal. So when we have that goal in sight, I'm going to just play with this thing until it looks like the look that I'm aiming for. Okay, so the first thing I see is that 2 is a bit of a painful thing. So I'm going to factor out that 2, leave the 5 until later. So if I do that, I have 2 times x squared subtract 4x. Because when we complete the square, it's a lot easier to deal with something with just the x squared in it. My next thinking is, all right, I know that I want to end up with this beautiful, perfect square like that. So I'm going to skip a line, and I'm going to write the perfect square that I'm aiming for. The perfect square that I'm aiming for is x, and it's subtract half of this value always. X subtract 2 squared is that perfect square that I'm aiming for. Because when we FOIL x minus 2 squared, I will get x squared, negative 2x, but then I have another term. If you were to FOIL x minus 2, I would have x squared subtract 4x, that's outside inside, and my lasts would be plus 4. So I have to introduce that 4, but you can't just willy-nilly add 4 unless you at the same time subtract 4. Don't forget to make it all balanced here. All right. Line number 2 is complete. I factored out the 2. Line number 3, I introduced plus 4 and negative 4. That doesn't change the question. Line number 3 isn't complete, but I do know that perfect square I was aiming for. So the first 3 terms, x squared, subtract 4x, that's outside inside, and the plus 4 are all this, if I did FOIL on it. So what am I left with? I'm left with the subtract 4. So I haven't dealt with him yet. I've still got the 2. I've still got the subtract 5. So I'm almost there. It almost looks like my goal. But that negative 4 in brackets is just kind of messy. It's not the look that I'm going for. So I'm going to do distributive law. So I'm going to do 2 times the bracket, 2 times the negative 4, and at least I get rid of that outside bracket. 2 squished up to x minus 2 squared, and then 2 times negative 4, and I still have that subtract 5. We are so close to the look that we're aiming for. 2 times x subtract 2 squared, subtract 13. Now I know the vertex. The vertex is 2, negative 13. That means my axis is x equals 2. I know whether I have a max or a min. This one opens up, so I have a minimum value of negative 13. Okay, let's have a go at another one. Y equals 3x squared plus 9x minus 1. I know my goal is to have it in vertex form. I know at this point, I know my y-intercept is negative 1. I know my A value is 3, so it opens upwards and is skinny. But to find the vertex, I need to change forms to vertex form. So my first step is to deal with that 3. So if I deal with the 3, I'm going to leave the -1 till later. It just makes the life a little easier. So if I factor out the 3, I have x squared plus 3x, and then I have the -1. Perfect. Line number 2 is complete. Line number 3 is my tricky one. So I'm going to skip it for a moment and come back to it. I know that I need a perfect square. Then I know it's x and a number squared. That number is always half of the x term above. So it's going to be 1.5 or 1.5. I'm writing 1.5 on the smartboard because it's kind of hard to be so neat. So I've got my perfect square. That's awesome. So I go back up a line and I say, all right, if I were to FOIL x plus 1.5 squared, I would have firsts, x squared. Outside inside is 1.5x plus 1.5x, which is 3x. Wahoo. But I also have plus 2.25. So I've got to have that number to have my perfect square. So if I've introduced 2.25, I also have to subtract it. All right. Now, -1 and 3. Line number 2 is complete. I introduced that 2.25 so that these 3 terms together give me my perfect square. I still have the -2.25 to deal with. It's all in brackets. I put those brackets up when I factored out the 3. So I've still got 3, still got the subtract 1. So line number 4 is complete. It's just not quite the look that I'm going for. These brackets are not the look that I want. I introduced them when I factored out the 3, and I had to do that. So now I need to get rid of them by doing the distributive law. Y equals 3 squished up to x plus 1.5 squared, and then also 3 times -2.25, which is -6.75. Okay, and then I still had to subtract 1. One more step. Y equals 3 squished up to x plus 1.5 squared, subtract 7.75. So I know all the other stuff now. I know that the vertex is negative, so to the left 1.5, -7.75. I know the axis of symmetry is x equals -1.5, and the minimum value is -7.75.